Hello everyone. In this video we're going to go about creating a main function so that we can test our stack, and if there's any errors that was produced in the video, well, we'll find them here. So our main.cpp, and we'll include our standard library, iostream. We'll include our two custom packages, dynamic stack and we'll also include dynamic queue.hpp. So we'll begin our main function, which will be our only function for this. So we're going to create a stack of integers. And I'm going to say sint. And we're going to print out its initial size. So let's test out the initial size. Initial size. Sint size. So this should print out 0. It should be empty. Now let's move on to, let's add some numbers. So we'll say sint.push. We'll add 5. We'll add 3 more values. Let's not make it too complex. So we'll add 19, and let's just add 45. Let's print the size again, just to make sure that we are incrementing the size like we're supposed to. Size after 3 pushes. We'll say sint.size, call it the size getter function. Right, and let's print the entire stack. And you know what? Let's test our getter. So we'll print top of the stack sint print. This is sprint, but you know what? Let's leave it as sprint. Let's generate some errors. Let's make that mistake. Alright, now we'll return 0. And now let's deal with the errors. So we'll use g++ and just main.cpp. Nice. Look at that. So we gotta go to the top. Way up to the top. Oh. That should be an underscore. Size should be an underscore. And if that's the case, that might be the case with Q. Yeah. So this should be underscores. Okay, why don't we try that again? Let's go all the way to the top. $197.18. Okay. $197. Ah! It should be stack.size. Okay, I gotta make sure that this is the same for... No, this should be fine. Yeah, so let's continue with the GCC. We'll take one error at a time. Actually, let's see if we can find that other error that's way up here. So in our main, we're missing an S. I'm missing a semicolon. There are no arguments for pop. Oh, this is supposed to be a capital Q. Okay, so let's fix the problem in main, because this is supposed to be sint, and it caught that. Let's go to dynamic queue. Because it says down here that we have an S, well, we're not supposed to. This is supposed to be a Q. Okay, what else? Let's see. When we compile, what else is there? Generating many errors. Oh, that should be top. Oops. Missing a semicolon. So dynamic Q. Dynamic Q. Oh, this should be DQ, not pop. And we can look at the size parameter here. Okay, so let's look at main. It should be the top. Here I'm thinking in Python, but now that's going to be alleviated. So now let's look into dynamic queue. Oh, let me just look for pop. There we go. So this should be DQ. Alright, because that's what we want to do. We want to DQ this stuff, not pop, because pop doesn't exist. What else is up here? What else have we solved? Okay, we solved this because we had to change it to top. We added semicolons to all these. Oh, we'll need to take a look at this. But we changed this to DQ because pop doesn't exist in the Q function. Its conversion, I guess, could be said, is that is DQ. So we need to go to line 201 in dynamic queue. And I go to that line by doing colon 201. And it says here, same problem as with the stack. This should be q.size. So now let's generate more errors. Oh. Okay. So let's run our algorithm. Initial size 0. Okay, this is good. Size after 3 pushes 3. We print the entire stack. Okay, this makes sense. Top of the stack is 45. Okay, not bad. So we found some errors that were generated with creating the class, which happens all the time. We fixed them one by one, and now everything works. So we think, for right now. So let's continue with main and try to build it to continue testing our class so that way we know it works. So why don't we start with creating a second stack? So let's say stack int second stack, and I'm gonna do that with the copy constructor, so sint. So we're gonna take a copy of it and we're gonna do second stack, and we'll call the print function just to make sure that everything was copied correctly. Then you know what? I'm tired of the 45 that's in the stack. So I'm going to pop it off. And let's replace it. Second stack with the number 8. Why? I don't know. Well, let's print it again just to test it. Here, we're just playing with it. We're playing with what we got. And now we have our second stack. So actually I'm going to put an additional print function here. Second stack. Just so we know that we're playing with another stack. So we can differentiate everything. Right. Okay, so second stack. Good. We print out the original stack with 5 in 1945, which is correct because that's how our s underscore int stack was. Now we have our second stack where we popped off the 45 and replaced it with the 8. So this is all correct. And in terms of making this clean, I'm gonna move this here. There we go. Okay. So we have this, and I think we're good for testing integers. Why don't we create a stack that's a float? And you know what? Let's just keep it simple. I'll call it A, and I'll call the parameterized default constructor. So here we call the unparameterized default constructor. Here we call the copy constructor of the class. So when it comes to the stack, all that we have left to test in terms of the constructor is just a parameterized constructor. So why don't we do that? We'll do that and we'll do a print just to make sure that it works. And then, you know what? Let's test the equals operator. So I'll say float, I'll call it b equals a. Let's print b just to make sure that it's working. And you know what? Let's push another value for a. What do we want to push? You know what? Let's do 2.6. Okay. Now we'll copy this to another float, a stack of floats called c. And let's print c. Okay, let's just test that this works. So here, actually, I'll just copy this line so you can differentiate float stacks. Okay, no problems. Let's print it. Float stacks. So we create a, and then we create it with a default value of 9.8, and that's there. And then we copy a to b, and that's correct. But then we push a with 2.6, and we copy it to another stack called c, and we print c. So everything is good. But one thing that I actually should test now, that I'd like to test, is the angle bracket operator. Let's test that. And then here what we'll do, I want to test the equals and not equals operator. So we'll compare A and C, and I'm about to break a rule where I'm going to keep everything on one line. Don't do this. Actually, we'll say nice if it's equal to each other, if A and C are equal to each other. Actually, no, I'm not going to do that. And then if A does not equal B, we'll print not nice. So why don't we test this out? So we'll test out the three. We've tested out the equals operator on line 31 and on line 35, and we're going to test the equals operator and the not equals operator. So what should we expect? Well, here we don't modify A or C, so this should be true. However, B was equal to A, but we changed the value of A once we push this value here. So actually, both of these if statements should be triggered. Why don't we test that out? Yes. Good. Very good. I think we've tested the extent of our stack pretty well. And why don't we start testing our queue? Okay, so if we're testing our queue, we'll go back into main. We'll have this down. And let's create a queue of doubles. Double Z. With Z, we're going to end queue 4.1, and let's add 4 values for this, just so that we keep it a little bit spicy for our testing. 2.3, and you know what, let's flip it. I'll say 1.4. Yeah. We'll test that our equals equals operator is working, because for the most part, we copied everything. Right, so the big factor to test is to test our NQ and DQ to make sure they perform the same. But for this right here, I'm going to make a copy of Z, and I'm going to DQ twice. Then what I'll do, I'll just print, and then I will NQ with 0.5. I'd like to test the front and the back getters to make sure that they work. And then compare that with Y itself. Okay, so this is our test for Q. Let's try it out. So here's our Q. We NQ'd 4.1 first, so it makes sense that it's all the way to the right. We copied it onto Y, and we DQ'd twice. This is the front, and when this is the front of the queue, and this is the back, and we compare that. Here's the front, which makes sense. Here's the back, which makes sense here. And here's Y, and here's Y after we NQ 0.5. So here's the back of the queue, and here's the front of the queue. So this all makes sense. So it looks like our class works after all. Quick disclaimer though, this is no way of talking about a completely full class, a full implementation of a class. This is just for teaching the theory and giving an example of that theory. Thanks for watching, and we'll see you for the next video.